Hello everybody, welcome back to another video. And in this video, we're going to be taking a look at a question from the IB Chemistry Paper 2 SL from the November 2017 batch. And even though this is from an SL paper, it shares content with HL as well. So both SL and HL students need to know this very well. And as you can see, it is worth a lot of marks, so it is an important question. Now, this is a question from topic one, which is stoichiometry. And I understand that a lot of students find difficulty in this subject, and hopefully this video will help to remove some of that difficulty and perhaps make you understand this concept a bit better than you did before. Now, it asks us, menthol is an organic compound which contains carbon, hydrogen, and oxygen. So basically, menthol contains carbon, hydrogen, and oxygen. That is all it's made up of, right? The complete combustion of 0.1595 grams of menthol. So we have 0.1595 grams of menthol. So combustion is basically it reacting with oxygen. When you burn something, it produces carbon dioxide and water. Oops. And they've told us that it produces 0.449 grams of carbon dioxide and 0.184 grams of H2O or water vapor. This is gaseous. These are all gaseous. Now, what I want to do is that I want to calculate the empirical formula of menthol. And I don't know what that is, obviously. I don't know what that is. So the empirical formula is a mystery to me. So this is CX, HY, and Z. This is just letters that I assign them because I don't know what these numbers are, right? You would usually have some substance. It would look something like C2H5O, for example, right? You would have substances like this, but these numbers that I write down over here, there's a 1 over here, but we don't write that in chemistry. But these numbers over here, that's what I want to find out. That's what is going to give me my empirical formula, right? So I need to determine that. And how do I determine that? The first step that I need to do is I need to find out the mass of carbon, the mass of carbon, hydrogen, and oxygen present in 0.1595 grams of menthol. And I need to do this because I need to then proceed to find out the moles of these substances in 0.1595 grams of menthol. And then I can proceed to find out their empirical formulas. And if you're a bit confused about what I'm talking about over here, I would recommend you to go and visit my previous video where I explain in detail how to calculate the empirical formula. So that will surely help you. I would recommend you go and watch that before you watch this if you haven't done so already. Anyways, now moving on. How do we find out the mass of carbon in grams? Well, we have a clue. This reaction produces carbon dioxide. And as you can see, carbon dioxide contains carbon. So we can use this information that we have been given to find out the mass of carbon that is present in 0.1595 grams of menthol. And it is obvious to say that whatever carbon is present in carbon dioxide comes from menthol because menthol isn't reacting with anything else. It is only reacting with oxygen. Thus, whatever carbon is being produced comes from menthol. So if we can find the mass of carbon which is being produced, that is also the mass of carbon which is being burned in menthol, if that makes sense. So how do we find out the mass of carbon? We know that this much of carbon dioxide has been produced. We just have to find out the mass of carbon in carbon dioxide. And how do we do that? Well, it's all about the ratio, right? The overall molecular mass of carbon dioxide is 44.01 and carbon makes up 12.01 units of that. So this is the overall mass of carbon dioxide, the molecular mass, and this is the relative atomic mass of carbon. So this is the ratio of the mass in carbon dioxide. So if we want to find out how much mass of carbon dioxide is contributed by carbon, this is how we find that out, right? This would be the ratio between the mass of carbon and the mass of carbon dioxide. And we need to multiply this by the mass of carbon dioxide produced, which is 0.449 grams, in order to determine how much carbon is present in 0.449 grams of carbon dioxide. Hopefully that makes sense to you. And this would give us an answer of 0.12253 grams of carbon. Now we need to do the exact same thing with hydrogen. We know that the molecular mass of water is 18.02 approximately. And and hydrogen makes up 2.02 units of this entire mass, because majority of the mass comes from oxygen, right? Which oxygen is a much heavier molecule in terms of relative atomic mass than hydrogen. So this is the ratio for the mass of hydrogen to the mass of the molecule water. And we need to multiply this by the mass of water produced in grams, which would be 0.184. And this would give us the mass of hydrogen present in 0.184 grams of water as 0.020626 grams of hydrogen. Now, how do we find out the mass of oxygen? Well, it's extremely simple because look, they have given us the overall mass of menthol that is being burned. So we just need to subtract the overall mass of menthol, which is 0.1595. We need to subtract this by 0.12253 plus 0.020626. And whatever is left over is the remainder of the mass of menthol, and that is the mass of oxygen, because that's the only mass that we haven't calculated yet, and that's the only thing that is left over. Hopefully this makes sense to you. And this gives us an answer of 0.01634 grams of oxygen. There we go. That is it. So what is the next step? Now that we have calculated the individual mass of each of the elements in menthol, in 0.1595 grams of menthol, we can find out their amounts in moles. And we need to do this in order to get their ratios to each other. And like again, if you don't know what I'm talking about, please revisit my video on empirical formula, which is just my previous video, and it'll all be clear once you watch that. So I'm just going to erase this over here to make some space for us. Hopefully you have understood what I have done. Oops, sorry. I'll just erase this of oxygen. Now we need to find out their number of moles. And I'm sure all of you know the formula for calculating moles. The formula for the number of moles is the mass in grams divided by the molar mass of the substance. So for carbon, the mass in grams is 0.12253, and we need to divide it by its molar mass, which is 12.01. And then for oxygen, sorry. So for carbon, like I said, it's 0.12253 divided by 12.01. For oxygen, it is 0.01634 divided by 16. And for hydrogen, it is 0.020626 grams divided by 1.01. Now, what is the answer to this? Well, you're lucky you have an access to the calculator, so you can easily calculate it. We get the number of moles of carbon as 0.01020 moles. And we get the answer for oxygen as 1.02125 times 10 to the negative 3 moles. So very, very small amount of oxygen present in this, in menthol. And what about hydrogen? We get 0.02042 moles of hydrogen. Now, what do we do after this? Now, this is part of the last step. The last step that we have to do is we have to divide the number of moles of each of these substances. We have to divide this by the number of moles of the smallest substance out of these three. And as you can probably tell, the smallest substance, or the substance which is in the smallest quantity in terms of moles in menthol, in 0.1595 grams of menthol, is oxygen. It has the smallest number of moles. So we have to divide all three of these, including oxygen, all three of these, by the number of moles of menthol. So let's do that. We do 0.0120, sorry, 1020 divided by 1.02125 times 10 to the negative 3, and we get the answer as approximately 10. You'll get, if you put this into the calculator, you'll get something like 9.998 or something close to 10. So, but we round it because obviously you can't have 9.98 carbons, right? That doesn't make any sense. Then we divide this by itself. If we divide 1.0215 times 10 to the negative 3 by itself, you're just going to get the answer as 1. And if we divide this by, so we do 0.02042 divided by 1.02125 times 10 to the negative 3, you get your answer as approximately 20. If you put this into the calculator, you'll get something around 19.88, but again, we round it up. Now that we have got all these numbers, what do? Well, you may have guessed it, these numbers correspond to these letters over here. This is the number of carbon, the number of oxygen, and the number of hydrogen present in menthol. And that is also our empirical formula. So as we see for carbon, we got 10. So this is 10. For oxygen, we got 1. So we just leave it empty. And for hydrogen, we got 20. So there we go. That is it. That is the empirical formula of menthol, C10H20O. I know it's a long question, long procedure, and perhaps you may even find it quite complicated, and I totally understand. But the way to understand this better is just to practice more questions. And of course, to watch, if you need to watch this video one more time, please feel free to do so. Watch my previous video on empirical formulas as well, and this will all make more sense to you. If you have any other questions regarding this concept or any other concept, please feel free to message me on my social media, put it in the comments below, or send me an email and I will be very happy to help you. Thank you so much for watching. I'll see you in another video with another question. Take care, everybody. Goodbye.